In today's lesson, you are going to learn about inscribed angles. And so we know from previous lessons that inscribed means in and inscribed means written, so it is an angle written on the inside. So again, an inscribed angle is an angle and the vertex is going to be on the circle, and then the two sides are going to be your chords. So looking at this example over here, here is my vertex on the circle, and here is chord AB, and here is chord BC. So that would be an inscribed angle. The intercepted arc is the arc that lies between the endpoints. So the intercepted arc would be from A to C. It's kind of the arc that it opens up to. So from A to C. Now, there's a special relationship between an inscribed angle and its intercepted arc. And that relationship is that the degree of the angle is equal to half the measure of the arc. So what that means is if I have the measure of ABC, switch colors here, A, B, C. Whoops, sorry, I'm using a fancy pen. So the measure of ABC is going to equal 1/2, and then it's going to be the measure of the arc of AC. So what that means is if this arc is 50 degrees, then you can half it to find this inscribed angle to get 25 degrees. And vice versa. So if you know an inscribed angle, the opposite of halving is to double it. So you can double it to go to the outside. All right. So there are some special relationships with that. So you can have an inscribed angle that intercepts a diameter. So looking at that, the special relationship, when an inscribed angle intercepts a diameter, then you're going to have a right angle. And so here is why. So here is my inscribed angle, BAC. The intercepted arc, I'm going to switch colors, it opens up from B to C. Now we know that's a semicircle, and we know semicircles are 180 degrees. And so if I'm trying to find the inscribed angle, I'm going to half 180, and that is why I get 90. Okay? So if an inscribed angle opens up to a diameter, you immediately know it's a right angle, and again, we know that's 90 degrees. So that's a special relationship that happens. So to save some time of halving 180, you can just remember that 90 rule. All right, there's one more relationship that happens. So you can have two inscribed angles that intercept the same arc. So let's look at this. I have an inscribed angle of ABD, and that is opening up to AD. And then I can also have the inscribed angle ACD, and notice that is also opening up to the same green angle AD. So if you have two inscribed angles opening up to the same intercepted arc, those angles are going to be congruent. So the reasoning behind that is they are both opening up to the arc length of AD, and so they have to be equal. So I know that angle B here is going to be equal to angle C here, but let's write it out. So the measure of ABD is going to be equal to the measure, I need 3 letters, and then C is going to be my vertex, so I can say ACD, or you can say DCA. Okay? But so these two inscribed angles are going to be congruent because they opened up to the same intercepted arc. All right, so those are the 3 rules that we're going to be using today with inscribed angles. So let's look at some examples. So we're going to stick to some numerical ones starting off. So on number 1, I noticed that they gave me the arc measure from W to Y, and I'm trying to find the inscribed angle, which is WXY, which is down here. So I know that the arc is equal to 1/2 of the intercepted arc. So sorry, your angle is equal to 1/2 of your intercepted arc. So all you have to do is take half of 62, and that is the same thing as dividing it by 2. So 62 divided by 2 is 31 degrees. Cuckoo. So if they give you the arc, divide it by 2 or half it. Let's look at another example. In this case, it gave me the inscribed angle, which opens up to all of this. So that would be the intercepted arc. Now it wants me to find the measure of that intercepted arc. Okay? And so now I'm going to be working backwards. So instead of halving it, I'm going to double it. So 113 times 2 is going to be 226 degrees. Okay? So that's how many measurements, whoops, that degree would be. Okay? Let's look at another one. So my inscribed angle, in this case, it wants me to find the measure of P, Q, and R. So P, Q, and R is angle Q. I notice that that opens up to a semicircle. I know semicircles are 180, and so we can use our rule up here that half of 180 is going to be equal to 90 degrees, and so angle PQR is going to be 90 degrees. Okay, so those are some straightforward problems. If you know the arc and you're finding the angle, you would half it. If you know the angle and you're finding the arc, you would double it. And if it opens up to a semicircle, it is 90. Now you can get a little bit more problem solving, obviously, included in these. So let's take a look at number 4. They gave me an inscribed angle that was 47 degrees. And then I am trying to ultimately find angle arc BC. Okay? I can't immediately find it, but I can use my inscribed angle knowledge. So this angle opens up to arc AC, so that's my intercepted arc. So I'm going to double this 47. So 47 times 2 is going to get me 94. So I know this arc is 94 degrees. Then you can use your knowledge of a semicircle to figure out what this measure of BC is. So we know semicircles are 180 degrees, and then I can subtract my measurement of 94 to figure out your missing arc of BC, which is going to give you 86 degrees. Looking at number 5, I noticed that they give me 2 arcs of 53 and 65, but the question is wanting me to figure out the measure of JKL, and I don't know why I marked through that. JKL. So JKL is our inscribed angle right here, which opens up to this really major intercepted arc. So before you figure out the angle measurement, you're going to need to find this arc, and we're going to have to go back to our knowledge of circles equaling 360. So 360, and let's take away 65 and 53, because that will tell us what is remaining in green. So if I subtract those two numbers, you get 242. So that major arc is 242 degrees, and again, the relationship between the inscribed angle and the intercepted arc is half. So let's divide that by 2 to get 121 degrees. Okay? And then lastly, this one looks a little bit different because we have lots of inscribed angles. Looks like 2 triangles, which probably is going to deal with overlapping arcs. So it wants me to find the measure of RST. So RST is this angle S. All right. So to figure that angle, I first need to find the arc RT. Okay, so I know this arc, and this arc, so I can take them all away from 360. So 360 subtract 75, subtract 139, and then subtract 64, and that will tell you what is remaining in that circle of 82 degrees. Okay, again, the relationship between the arc and the inscribed angle is half, so half of 82 is going to be 41 degrees. All right, let's jump to our next problem. It wants me to find the measure of angle RUT. So RUT is here, angle U, which I notice opens up to the same intercepted arc of 82. And since the green angle and the red angle open up to the same arc, they are going to be congruent and also be 41 degrees. Okay? All right, so here is just numerical practice of how to find inscribed angles. In the next video, we are going to talk about equations. All right, so if you're feeling comfortable with numeric, you can watch part 2 with equations. Thanks for watching.